Hey there, we're going to show you a moles to grams problem now, and I wanted to give you a couple of pointers before we start. The first pointer I want to give you is one that you're going to hear a lot, and that is start with a balanced chemical equation. Now if you're in regular level chemistry, you're probably going to get the equation pre-balanced, and that's nice, and you'll get the right numbers in front of the substances that are there, and that's all great. But if you're in honors or if you're in a more advanced AP level class, watch out, because sometimes they give you the equation and it looks like everything's fine, but it hasn't been balanced. So watch out for those additional steps and make sure you're dealing with a balanced chemical equation. Alright, second thing is that once you have the balanced chemical equation, those coefficients represent the molar ratios. So now you know if substances are related like 2 to 1, 1 to 2, because those coefficients reflect the molar ratios. You also need a periodic table, because if you're going to look up masses, you really need a periodic table handy, and nobody expects you to know the masses for, hydrogen or carbon off the top of your head. Now, I might, because I'm an expert at this stuff, but you don't have to. And even still, for some of those elements, even somebody like me needs to look up stuff in the periodic table once in a while. All right, now, these kinds of problems you're going to need to use not one, but 2 conversion factors. So get ready, I'm going to show you how it's done, and I'll see you at the end of the video. All right, somebody ordered a grams to moles problem, and here we are serving it up hot and fresh. Okay, so look at the equation. You can see that it's already been given to us balanced, which is nice. So let's read the problem and figure out what to do. Here it says, how many moles of ammonia are produced when 56 grams of nitrogen reacts completely with hydrogen? So the given information is substance A, and what we're looking for is substance B. Now, even though hydrogen is mentioned here, I know that they really want the ammonia because it's closer to this question word, how. How many moles of ammonia? That is what the problem is asking for. This is just some additional information that we really don't need to worry about. The fact that it reacts completely with hydrogen is a nice technicality. So, substance A is nitrogen. That's this substance right here. And what we're looking for is ammonia, which is that substance there. Now, in order to get from A to B, we're going to start off with grams of A. That's our first stop. And we're going to change that into moles of A. That's going to allow us to do a lot of different conversions. So once we're at moles of A, we can easily flip into moles of B. And once we do that, we are done. All right, so I'm going to put my red pen away, and I'm going to use my black pen to take care of business here. So 56 grams of N2 is what we're starting with. You're going to write that over 1, because that's what we start with. And I need a conversion factor that allows us to go from grams to moles. Now, we're starting with nitrogen. And I want to caution you, because a lot of students, they'll look up nitrogen and they'll say, oh, the mass of nitrogen, it's 14.01. I'll just write that down here. Wrong. This says not just nitrogen, but it says N2. So we do look up the nitrogen, and it is 14.01, but we have to double that, because we're not just dealing with nitrogen, we're dealing with nitrogen gas, or N2. So if you'd like, you can use your calculator and you can multiply that times 2, and you'll find that the mass is 28.02 grams of N2 for every 1 mole of N2. All right, now we're done with the periodic table, because once we find the mass of nitrogen, that's it. That's all the masses we need to figure out. Our grams cancel nicely, by the way. And that should always happen if you're solving problems in this dimensional analysis style. Okay, now to go from moles of A to moles of B, I need a conversion factor that relates the two. Now, here, the equation doesn't have a number in front. And that's okay, because chemists don't write ones in a chemical equation when there's only 1 mole of that substance. So this is actually a 1 to 2 ratio. So this is 1 mole of N2 for every 2 moles of NH3, which is of course ammonia. So to get this conversion factor, going from moles to moles, I look at the balanced chemical equation. All right, now I know I put the numbers in the right place because my units cancel. The one that's in the top here cancels with the one in the bottom here. And I'm basically done, people. We are ready to knock this thing out. Put the boxing gloves on. Here we go. Multiply the tops and divide the bottoms. 56 times 1 times 2. Divide the bottoms. Divide by 1. Divide by 28.02. And divide by 1. And bam. Now, this is pretty darn close to 4. So if it's all right with you, I'm just going to say that this is 4.0 moles of NH3. And I'd like to put a box around my answer just to make it clear. And we are done. Excellent. Okay, now, one suggestion I have for you is, if you understood what happened, great. Take a moment now and start the video from the very beginning and pause it on the question. I want to see if you can follow the process that I used from beginning to end. And if you can do that, then great. If you get stuck, then press play on the video up to the point where you get stuck, watch the next step, and then hit the pause button again. See if you can carry the problem to the end from that point forward. And the reason why I'm asking you to do this is because I want you to learn the process. If you learn the process really well, that's going to make it easier for you to decode problems that you may never have seen before. Because if you understand the process and apply the process in the right way, you're going to get the right answer. And that's what I want for you. I want you to get nice answers, correct answers, and I want you to get good grades. So that's it for now. I will see you next time. Hey, wasn't that awesome? All right, well, maybe it wasn't awesome, but at least you now understand a little bit more chemistry than you did before. All right, so a couple of key points to keep in mind for all of these stoichiometry problems. First, you always have to start with a balanced chemical equation. That's a must. You can't go anywhere without it, because otherwise your conversion factors get all screwed up, and then you get wrong answers, and then wrong answers don't make you happy. All right. Second thing that you have to keep in mind is that along the way you might feel confident, and that's good. I want you to feel more confident. But I want you to keep practicing as well. I don't want you to stop just because you were able to solve one problem correctly. You need to keep going and practice a few problems until it's like tying your shoelaces. You know this backwards and forwards. All right, and then the final thing I want you to keep in mind is that if you're running into trouble, always make sure that you're labeling your units along the way. So that way, if there is a problem and you don't get the right answer, at least you can backtrack and kind of problem solve and figure out what step might have gone wrong. All right, that's it for now. Remember, watch another video, get good at chemistry, and I'll see you soon.